So, a water wheel is a simple machine. You guys take notes in here? There you go. I'd write that down because that's really important to know that a water wheel is a simple machine. So while you're writing that down, I'll just tell you a simple machine is, it doesn't mean it's easy. It just means that it's not, doesn't have very many things to it. Now the two most important parts of this simple machine is that the water wheel can change the size or the magnitude of the force, and it can change its direction. And I'll show you how this works in a second, but you can see I changed, let's go to this one. The water was flowing this way and the stones are grinding this way, right? So I was able to change the direction. The other thing that we'll talk about in a little while is I changed the force, right? Because this water's flowing here, but how much did I move?
A lot.
Thousands of pounds. Remember we talked about that stone? So I moved thousands of pounds with a stream. So that's what this water wheel can do for us. That's what a simple machine can do for us. It can change the direction and the force that we're using. So there are other simple machines. In fact, there are 6 kinds of classical machines. Levers. We're going to talk about levers for a little bit. Wheel and axle. We just talked about wheel and axles. Pulleys. Anybody seen a pulley used?
I used to have one I had a bunk bed. My mom was pull it over and have this basket.
So you could pull a basket up to your bunk bed. That's cool. What else? Did I see somebody else?
I had one on my treehouse.
On your treehouse. Did you guys ever see an old movie or a cartoon where they had a pulley pulling up a piano?
Yeah.
So you see that's a simple machine. It's changing the direction and the force, right? Because 1 or 2 guys can pull up a piano. Unless you do what? Which always happens in the movie.
Drop it.
They drop it, right? And then it comes crashing down. How about an inclined plane? Does anybody know what an inclined plane is?
Oh, it's a wrap.
It's like a ramp. That's what I like to call them. I can never remember inclined plane, so I call it a ramp. It can change force too. You believe that? What happens if you put me in a wheelchair and you come up to steps or a ramp? Which one are you going to use?
Ramp.
Why?
Because it's bumpy and the ramp is going to be smooth.
Well, you're going to be able to get me up the ramp, right? Because you can do what? You can push me up the ramp, right? The stairs, what are you going to have to do? Lift, right? So you see, with the ramp, I get a little bit force multiplier. But like Dave said, there's always a trade-off. How is the steps shorter or is the ramp shorter?
Steps.
Steps are always shorter. The ramp takes a little bit more distance, but you use less force. Okay, there are also wedges and screws, and we'll talk about those some other day. But here's some everyday examples of simple machines. You didn't know you had all these simple machines. Anybody ever use a hammer?
Yep.
That's a simple machine. We'll show you how to use that. Everybody use an axe? Yeah, that's a simple machine. You've seen loading ramps before, right? On moving trucks, so they can push it up. Pulleys, we talked about that. Crowbar. All of these are simple machines that make our life easier. So, now we want to spend a little bit of time on understanding levers and how levers relate to wheels and axles. This is a lever. Let me tell you the 2 parts of the lever. The lever has a fulcrum, or a pivot point, and this one right here is a big triangle, big block of triangle wood like this, and this sits on the ground, and this board is sitting right on top of it, right? And then this board goes out here, and then I have 100 kilograms here. How much is that in pounds? About 220 pounds, right? Is that a lot?
Yeah.
Yeah. So if you weighed over 220, you'd be really heavy, right? And then over here I got 5 kilograms, and that's about 11 pounds. Do you guys know anything that looks like this? Have you ever used anything that looks like this?
Yeah.
What?
A seesaw.
A seesaw. Who said that? Good answer.
Good answer.
Did you ever use a seesaw? Okay? So what happens if a heavy person gets on one side and a light person gets on one side? Okay, so if I put 100 kilograms here and 5 kilograms here, that's 5 kilograms going to go flying in the air, right?
Yeah, if the fulcrum's in the middle.
If the fulcrum's in the middle. But I've got the fulcrum over here. And a matter of fact, in this example, how many times do I have to multiply 5 kilograms to get to 100 kilograms? 20. Okay? So in this example, what I did is I put this fulcrum here where this 100 kilograms was sitting exactly 1 foot away from that point. Just 1 foot. Okay? Then I walked out here, this is a big board, and I set 5 kilograms down that was exactly 20 feet away. And guess what happens? It's balanced. It just sits there. It's balanced. Because levers give us mechanical advantage. And the mechanical advantage, this is a little diagram of that same thing. If we have a big weight on this side and it's pushing down with some force, and we have a little weight on this side, we can figure out that if we multiply the distance away from the fulcrum by its weight, distance times the force, if this distance times this force is the same, it will be balanced. Okay? So in our example, right, we were 1 foot away and 100 kilograms, so that was 1 times 100, 100 kilograms. But in this case, we're 20 feet away and 5 kilograms away. That's 100, so it would be balanced. And it would just sit there balanced. As a matter of fact, what we can say is, if we do some arithmetic on this, we can say the mechanical advantage that we get is the ratio of the distance from the force weight to the load weight. So D2 times D divided by D1. So in this case, it was 20 feet divided by 1 foot, gave us a mechanical advantage of 20. Okay? Now, do you think those two things, do you believe me that those would be balanced?
Yeah.
Okay, I'm going to prove it to you in a little bit. I need 2 volunteers for just a second. Let me see. This young man back there in the back in the light blue. And I need 1 more volunteer. Let's see. This young lady back here. Come on up here. Okay. So I got a question for you. Okay. See this good-looking guy right here? See this good-looking. Oh, see this guy here? Okay, can you kind of just lift him up and hold him there for about 15 minutes? Huh? You can't? You can't? I bet you can. Okay, let me show you how. Okay, you come over here. You come over here. You're still good-looking. That's all right. Have a seat. Have a seat. Turn around.
Peter Totter, sit down.
Have a seat. You come over here. And very gently, you just press down there. Huh?
Yeah,
Can you stand there for 15 minutes? Okay, gently let him down gently.
Drop.
Wait a minute. I want to show you. Sit back down. I want to show you how strong I am. You sitting down? Okay. So, you can hold him up in the air for 15 minutes. Why?
Leverage.
Because he had leverage, had mechanical advantage. You want to see how strong I am?
Yeah. Sure.
Who said no? The good-looking guy said no after I've been so nice to you. Want to see my muscles?
Hello.
See the muscles bulging out there?
Yeah.
Huh?
Throw.
Okay, that's good. Why can I do that again?
Leverage.
Do you think I can lift him with 1 thumb?
No.
Without my lever?
No.
No. So, levers or simple machines make work easy. Okay, write that down. Simple machines make work easy. That's why we have so many of them. It just makes our life easy. Okay. Now I found a good-looking guy. Now I need a really strong guy. I mean, stronger than me. You're stronger than me? Okay, come on with me. You're stronger than me.
Oh, you're okay.
Okay, so I brought this piece of wood in. We're going to use it on the lever, but David started nailing nails in it for me, okay? So I don't like the nails in there. Don't bend my nail, though, because I need it for later, okay?
Okay.
Go ahead and take that nail out.
It's gonna be hard.
Wait a minute. Didn't you tell me you were strong?
Stronger than you.
You saw my thumb.
Use simple
Yeah.
machine, Richie. Use the simple machine.
Okay.
No. You said you were strong. Pull
What is
that out.
black and yellow right
All right, you can't do it. Go sit down. Okay, I need a really weak person. Who's the weakest person in here? Are you weak? Let me have you. You look like a weak person. Okay, we're going to use a simple machine.
Oh, yeah.
Come over here.
Oh yeah, that's something.
Okay, now we're going to use a simple machine, and you want leverage, so you want to press up there. Just press down real slow. Maybe 2 hands. Just keep going. Just real slow. Keep going. Keep going. Keep going. Keep going. Super.
Hey.
Stronger than you, Richie.
Use a simple machine.
Well, you said you were strong.
It's stronger than you.
There's a difference.
Okay, so this is the same point, right? Thank you for doing that.
She's not.
People that aren't as strong as other people can be stronger than other people if we use a simple machine, right? I mean, if we didn't have a crowbar and we ever put a nail in the wrong place, we couldn't get it out. So we have to have simple machines to make our life a little bit easier. So there are 3 kinds of levers. There's a first-class lever. That's what we've seen here. That's where the fulcrum is in the center, the load is at one end, and the effort's at the other. These aren't worse. They're just different. Okay. We call this a second-class lever, where we put the fulcrum there and the load here and our hand here. This is like a soda can, like a bottle opener, right? When you hold the bottle, right, you go like this and pop it open, and the load is in the center.